The dawn of a groundbreaking scientific partnership is here, unveiling the first detailed radar images of Earth like never before. The NASA-ISRO Synthetic Aperture Radar (NISAR) satellite, developed through an innovative collaboration between NASA and the Indian Space Research Organization (ISRO), has successfully transmitted its initial images, signaling a significant leap toward fully operational scientific contributions expected later this year. Acting NASA Administrator Sean Duffy expressed enthusiasm over this accomplishment, stating, "The images captured by NISAR highlight what can be achieved when we come together with a shared vision focused on innovation and exploration." This is just the beginning. NASA is committed to continuing to expand on the extraordinary scientific advancements of both the past and present, further ensuring our leadership in space through what we call gold standard science. The first images from this cutting-edge satellite, which launched on July 30th, illustrate its superior detail in scanning the Earth. This capability will empower decision-makers across various fields, such as managing disaster response, monitoring infrastructure, and enhancing agricultural practices by providing vital information that can be acted upon promptly. Amit Kshatriya, NASA's Associate Administrator, remarked on the implications of these findings. By gaining insights into the functioning of our home planet, we can refine our models and analyses of other worlds within our solar system and beyond. This knowledge will help us as we embark on humanity's monumental journey back to the Moon and even onward toward Mars. He emphasized that the successful transmission of these initial images stands as a remarkable illustration of how collaboration between two nations separated by vast distances can yield significant advancements for global benefit. On August 21st, NISAR's L-band Synthetic Aperture Radar (SAR), developed by NASA's Jet Propulsion Laboratory (JPL) in Southern California, captured stunning images of Mount Desert Island off the coast of Maine. In these images, water is depicted in dark tones, lush green areas signify forest cover, and magenta shades indicate hard surfaces such as buildings and bare land. Impressively, the L-band radar has the capability to resolve objects as small as 15 feet, 5 meters, revealing narrow waterways slicing through the island and the multitude of islets scattered in the surrounding waters. Just 2 days later, on August 23rd, the radar captured detailed data from northeastern North Dakota, crossing over Grand Forks and Walsh counties. The imagery features rich forests and wetlands adjoining the Forest River, which flows through the middle of the frame from west to east, alongside agricultural fields spanning both the north and south. Darker patches signify fallow fields, while lighter tones indicate the presence of pastures or crops like corn and soybeans. Circular patterns visible in the images reveal the use of center pivot irrigation techniques, showcasing the L-band SAR's proficiency in identifying distinct land cover types, be it wetlands, forest areas, or human-made structures. These images are not mere photographs. They represent invaluable data instrumental in monitoring the health and changes in ecosystems, particularly the growth or decline of forested and wetland areas. Additionally, they will aid in tracking the development of crops throughout their growing cycles across the globe. These first images are nearly a sneak peek at the robust scientific data that NISAR is poised to deliver, commented Nikki Fox, Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington. Data and insights derived from NISAR will allow scientists to investigate Earth's evolving land and ice surfaces with an unprecedented level of detail, enhancing the ability of decision-makers to react to natural disasters and additional pressing challenges. She further noted that these remarkable early images are a testament to the relentless effort of hundreds of scientists and engineers from both NASA and ISRO, who have dedicated years to constructing this meticulously designed observatory, equipped with the most sophisticated radar technology ever launched by either agency. Employing a 10-inch, 25-centimeter wavelength, the L-band radar penetrates forest canopies, enabling precise measurements of soil moisture and detecting slight land movement down to fractional inches. This precision is crucial for understanding land surface shifts that occur prior to, during, and following seismic activity, volcanic events, and landslides. The preliminary images from the L-band are just a taste of what the mission team anticipates will be accomplished once the scientific phase kicks off in November. The satellite was elevated to its operational orbit, an impressive altitude of 464 miles, 747 kilometers, in mid-September, and is set to monitor Earth's land and ice surfaces every 12 days, twice over. Interestingly, the NISAR mission also includes an S-band radar component provided by ISRO's Space Applications Center. This radar operates on a 4-inch, 10-centimeter microwave signal, which is exceptionally adept at detecting small vegetation. Consequently, it proves effective for tracking specific agricultural practices and grassland ecosystems. A remarkable feature of the NISAR satellite is that it uniquely carries both L and S-band radars, allowing for comprehensive monitoring. With a massive drum-shaped antenna reflector measuring 39 feet, 12 meters across, the most substantial that NASA has ever launched into orbit, the satellite promises to collect extensive data that will significantly contribute to our understanding of the planet. The development and successful deployment of NISAR exemplify the enduring partnership between NASA and ISRO, anchored by years of joint technological and programmatic efforts. Significant contributions came from various ISRO centers, including the Space Applications Center, which supplied the S-band radar, and the U.R. Rao Satellite Center, which facilitated the spacecraft bus. Moreover, the Vikram Sarabhai Space Center played a key role in providing the launch vehicle, with support from the Satish Dhawan Space Center for launch services. Operations regarding radar deployment and monitoring are actively managed by a network of ground stations belonging to ISRO's telemetry, tracking, and command setup. Under the management of Caltech in Pasadena, NASA's JPL leads the U.S. involvement in this project. In addition to developing the L-band SAR, antenna reflector, and boom, JPL is responsible for the high-rate communication subsystem, a solid-state data recorder, and the payload data management subsystem. NASA's Goddard Space Flight Center, located in Greenbelt, Maryland, oversees the Near Space Network, which is tasked with receiving NISAR's L-band data. Curious to learn more about the NISAR mission and its capabilities? Visit their dedicated site at NISAR, JPL, https://NISAR. So, what do you think about this remarkable partnership? Do you believe that such collaborations will fundamentally change our approach to Earth science? We'd like to hear your thoughts in the comments below.